So in this reaction, we reacted sodium bicarbonate, baking soda, with hydrochloric acid, and we produced carbon dioxide gas, water, and sodium chloride, table salt. So very similar to when you have a volcano made from baking soda and vinegar. And we use stoichiometry to figure out our percent yield of the reaction. So figuring out if this is an efficient reaction, based on the amount of starting material we put in, did we get the maximum amount of products out? Let's look at your data that you collected. We have the mass of sodium bicarbonate that we started with, so this is important for when we're calculating the theoretical yield. You took the mass of your entire setup before you set up the actual reaction, so this is your mass of your big beaker, plus the test tube containing your sodium bicarbonate and water, plus the small beaker and your pipette. And after that, you added hydrochloric acid slowly until you didn't see any more bubbling, and then you weighed your entire setup again. So that will be everything minus the carbon dioxide that bubbled off. The next thing you wanted to do was figure out how much table salt, so sodium chloride, you produced in the reaction. So you poured it out into a watch glass and you evaporated off the water. So you took the mass of the watch glass before and after you collected the sodium chloride. All right, now let's look at some of the calculations. So the first thing you want to calculate is a theoretical yield. So based on the amount of reactant that you put in, or starting material, what's the maximum amount of product that you can get out of the reaction? It's always important to calculate a theoretical yield. Let's look at the two calculations for carbon dioxide and sodium chloride. So we're starting with grams of sodium bicarbonate that we weighed in the lab. So eventually we need to get to grams of carbon dioxide. We're using the balanced equation for stoichiometry, so we have to go through moles first. We have to convert from grams of sodium bicarbonate to moles of sodium bicarbonate. We can use the mole ratio given from the coefficients in the balanced equation to go from moles of sodium bicarbonate to moles of carbon dioxide. And finally, we can use the molar mass of the carbon dioxide to go back to grams. Let's show this whole calculation, plug some numbers in. So for both cases, we're starting with 1.349 grams of sodium bicarbonate. So always what we weighed out at the very beginning of the reaction. We want to make these cross cancel, so we want the molar mass on bottom, so 84.01 grams of sodium bicarbonate for every 1 mole of sodium bicarbonate. The next thing we want to do is go back to our balanced equation. So if we look, our equation is already balanced, so our mole ratio is just 1 to 1. So if we go back down, we know that for every 1 mole of sodium bicarbonate, we should produce 1 mole of carbon dioxide gas. And the very last thing is we have to go to grams. So for every 1 mole of carbon dioxide, our molar mass is 44.01 grams of carbon dioxide. So everything cross cancels, and what you get is 0.7077 grams of carbon dioxide. So keeping in mind significant figures, we start with 4 significant figures, so we have to end with 4 significant figures. Let's do the same thing for the sodium chloride. And the roadmap is very similar. The only difference is at the end we need the molar mass of the sodium chloride instead of the carbon dioxide. So we'll start with the same 1.349 grams of sodium bicarbonate. And again, we're going to use the molar mass, 84.01 grams of sodium bicarbonate for every 1 mole of sodium bicarbonate. And the next thing we want to do, even though the ratio is 1 to 1, we know that for every 1 mole of sodium bicarbonate that we use, we're producing 1 mole of sodium chloride. And the last thing is we need to use the molar mass of sodium chloride. So if we go back to the beginning, we know that for every 58 So remember that we have to have moles on the bottom. So for every 1 mole of sodium chloride, our molar mass is 58.44 grams. Always check to make sure everything cost cancels. So the last thing is, go ahead and plug it into your calculator and you should get 0.9384 grams of sodium chloride. So now that we've done the harder part, calculating the theoretical yield, let's figure out our actual yields. So this is going to be what we obtained from the reaction, what actually happened in the experiment. Let's look at both of the products that we're looking for. The first thing is we want to have the mass of carbon dioxide produced. So remember, for this, we weighed our setup before, and the mass of that was 152.146 grams. And then after we ran our reaction, we weighed it again, and it weighed 151.463 grams. Okay? So look at the two numbers. After your reaction, since some of the carbon dioxide gas escaped, that mass should be less after you run the reaction. If we subtract these two, we get 0.683 grams of carbon dioxide. So that's our actual yield from our experiment. What about the mass of sodium chloride produced? So we weighed it out onto a watch glass. The first thing we need is the mass of the watch glass plus the sodium chloride that we collected. And that mass was 49.382 grams. And then we want to subtract the mass of just the watch glass alone. So that will be 48.482 grams. So keeping in mind we're doing subtraction, we should have 3 places after the decimal, so the final answer is 0.900 grams of sodium chloride. We have to put the zeros in so that way we have 3 places after the decimal. The last thing we want to do is figure out the percent yield. So how good of a reaction did we run? And remember that a percent yield is always going to be the actual value, so the actual yield that we obtained from the experiment, over the theoretical. And since it's a percent, we have to multiply by 100%. Okay, so always what you got experimentally, which is the actual, over the theoretical multiplied by 100%. So let's look at both cases. For the carbon dioxide, what we obtained experimentally is 0.683 grams. What we calculated for the theoretical yield was 0.7077 grams, and we want to multiply that by 100%. We're dividing, so we should have 3 significant figures in our answer. We get 99.5% for carbon dioxide. So a pretty good reaction. What about sodium chloride? What we obtained was 0.900 grams, and what we calculated as a theoretical yield was 0.983 grams. Times 100% gives us 95.9% of the sodium chloride.